Hello everyone. So today's question is lowest common ancestor of binary search tree. So let's read the question. Given a binary search tree BST, find the lowest common ancestor node of two given node in a BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in a T that has both P and Q and as a descendants. So let's take example and let's try to analyze this. We have given a binary tree and two nodes. That is, in this case, we have given two nodes as a P and Q. It will be P is a 2 and Q is a 8. So the common ancestor will be 6, and for the second test case it will be P is given as 2 and Q given as 4. So 2 and 4. So the lowest common ancestor will be 2. Okay. Now the brute force approach is that I will find path for the both node from the root and then compare its path, both of the part, and whenever I found a mismatch then I'll return the previous node. So let's take an example. Let's say P is in the first case, I'm taking example 1 and I'm defining P of P equal to 0 and Q equal to, let's say, 9. So I'm defining in the test case 1, I'm defining P and Q. So path for P, it will be like 6 and 2 and 0. So this is the path for P from the root node, and then we will find path for Q. It will be 6 to 8 to 9. So this is the path for Q, and we have to find lowest common ancestor. So I'll keep comparing. 6 is 6 matches, then I'll move the both the pointer, and then there is a mismatch. After getting a mismatch, then I'll return the previous value where it will be matched, so it will be 6. So the answer of this will be 6 as a ancestor. It is a common lowest common ancestor. You can traverse from the left side, right side as well, going from here to here. Whenever you find a first match, then you will return the that is your lowest common ancestor. So this is the brute force approach. uh, you have to find the path. So it is the very not good idea to solve this using this method. So because the in the question it is mentioned that it is a binary search tree, so we have to use this property. And what is the properties of binary search tree? Left subtree, left value, it will be left value is less than or equal to root ka value, and it is also less than or equal to right ka value. So this is the property of binary search. So we have to use this, and using this we can reduce the time complexity as well. So let's see how we can reduce this. So I have given a two nodes, and there is the possibility is three case. There is only three case you have to consider. Let's see one by one. So case first case, what is the first case? What if the, let's say, both nodes value is lie on the left part. Let's say you have a 6 as a root, and the two given nodes will be like a 4 and 5. So both values P and Q lie on the left part. So I'll search on the left subtree, not the right, because there is no mean to search on the right subtree. So I will search on the left subtree. Okay, and there is a second case is same as the first case. What if the value of two nodes, it is both are greater than the root node? It will be like 8 and 9. Then I'll search on the right subtree rather than the left subtree, because it does not mean to search because it is greater, 8 is greater, and 8 is greater means both of the two nodes value is greater than the root node. So I'll search on the right part. Then there is a third case, which is, what if root node is 6 and then one node is lie on the right left subtree, and another one is lie on the right part. So this in this case the answer is 6, because it is the lowest common ancestor of these two nodes. So these three case you have to remember, and according to that we will code it. So let's try to code it. And we are not confirm which value is low and which value is high in terms of given node. So let's do that first. If I'm considering P is uh, lower, so it will be, if P is greater than Q ka value, if it is greater, then I'll swap this. How can we swap this? Just recursively call a 1 second. Just recursively call root, and for P I'll just swap it with Q, and Q it will be P. So I'll swap this and I'll return this. Okay, now I know P is lower, P value is lower and the Q value is higher, so I'll compare. Let's, if P value is less than or equal to root ka value, and root value is less than or equal to Q ka value. This is the third case I am handling. So in this case I'll return simply return root. Then if P of value is less than or equal to root ka value, it's not equal to, like I'm considering the handling the first case, test case. So the I have to check P value and Q value is should be less than root value. So Q value less than root ka value. So it the answer lies uh, ancestor. Okay, ancestor may lie, must, sorry, may not, must lie on left subtree. So go to left subtree if exist. So go to left subtree. So I'll return root ka left and pass the P and Q as it is. And else if it is not, then the ancestor must lie on the right subtree if it exists. So I'll return root ka right P and Q. Okay, so I think I'm done. Let's try to run this. So I have to handle a base case as well. If what if I think there is no need. Let's try to submit and see if it is running. Okay, accepted. So we can, rather than doing recursion, we can do iteratively as well. So how we are going to do that? So let's run a while loop in this root until root is not null. Run, keep iterating, and just copy this piece of code. Let me copy and comment this and paste it over here inside the while loop. uh, Rather than returning, if the value p value is less than, or so if the third case is there, so I'll return directly root. Otherwise, rather than calling recursively, I'll just put root equal to root ka left, and here it is root equal to root ka right. So after the uh, while loop over, then I'll return simply root. Okay, that's it. Let's try to run and see. So this is an iterative solution, and it is also got accepted. So that's it. Thank you.